about the types of electrolyte, there are only two types will be there. One is strong electrolyte and the one is weak electrolyte. According to the ARRHENIUS, what is an acid? Acid is a substances which has a capacity to donate the H plus ions onto the proton. In a HCl as well as in a HNO3, so how many replaceable hydrogen will be there? Only one. Hence it is monobasic in nature. When a substance is accepting a proton, it becomes a conjugated acid. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called equilibrium. In our last class, we have learnt about the factors which are influencing the equilibrium or to the equilibrium. So, by understanding the Lee-Chatterjee's principle, we have learned that there are so many factors which can also affect to the equilibrium, that may be in the form of concentration or the temperature or the pressure. We also understood that the catalyst has no effect on the equilibrium. Today let us move on to the ionic equilibrium by understanding what are the electrolyte, and also we are going to understand the types of electrolyte and the theories of acids and bases was given by the ARRHENIUS theory of acids and bases, Bronsted-Lowry theory of acids and bases, conjugated acid-base pair, conjugated base for the acids, and amphoteric substances we are going to discuss in this session. Okay. First of all, after dealing with this equilibrium part, we are also going to understand the ionic equilibrium. Okay. In this, we are going to understand the two main important terminology. One is electrolyte and the one is weak electrolyte. Let us first understand what is an electrolyte. Okay. These are the substances which conduct the electricity in the molten state as well as in the solution state. The best example is sodium chloride. If you take the sodium chloride, in the molten state also it can conduct the electricity, whereas in the solution state also it can conduct the electricity, and this is because it forms a sodium cations and a chloride anions. Because of the ionization, it can conduct the electricity in the molten state as well as in the solution state. We have one more electrolyte that is known as non-electrolyte. The substances which do not conduct the electricity in the solid state, both in the solid state as well as in the solution state, such electrolytes are said to be a non-electrolyte. Example, benzene and ethanol are the best example. And for the electrolyte, we can take sodium chloride and H2SO4, CH3COH, that is acetic acid. We can take the plenty of example for this. Next, we are going to understand the types of electrolyte. So, already we have understood that electrolytes are the substances which can easily conduct electricity in a solid state as well as with a solution state. Now, if I talk about the types of electrolyte, there are only two types will be there. One is strong electrolyte and the one is weak electrolyte. The strong electrolytes are the electrolyte which undergo complete ionization in the solution. Example, sodium chloride is going to ionizes to form a sodium cation and a chloride anion. So, these are the electrolyte. In the solution state, what does it do? It will do complete ionization. Hence, such electrolytes are said to be strong electrolyte. You can take the example of H2SO4 also. So, the sulfuric acid which undergo ionization and give rise to the 2H plus ion plus SO4 2 minus ion. So, in the solution state, it can easily get converted to give respective cations and anions. Hence, they are known as what? Strong electrolyte. We have one more electrolyte, that is weak electrolyte. These are the electrolyte which undergo partial ionization. They are not completely ionizing. It is undergo partial ionization. Example is acetic acid and ammonium hydroxide. I will write for the acetic acid, that is CH3COOH, which undergo partial ionization to give CH3COO minus and H plus. This is a partial ionization where the reactant can also give rise to the product, whereas the product themselves can react to form a reactant. Okay. So this is known as what? Partial ionization. Hence they are known as what? Weak electrolyte. In the solution of weak electrolyte, the equilibrium will be established between the ions and undissociated molecule. Hence it is also known as what? Ionic equilibrium. Suppose if I take the example of acetic acid, or you can go with the example of ammonium hydroxide. Here it undergo what? Partial ionization, as we have understood. So this is a dissociated molecule. The undissociated one can also set a equilibrium between the dissociated molecule with the undissociated molecule. Such equilibrium will exist between the ions. Hence they are known as what? Ionic equilibrium. So hope you all understood that why ionic equilibrium is very important to study under the equilibrium chapter. Okay, you are going to study the equilibrium which exists between the ions. Next, we are going to understand the Arrhenius theory of acids and bases. So usually when we are studying the theories of acids and bases, there are three theories will be there. One is Arrhenius theory of acids and bases. Next, Bronsted-Lowry theory of acids and bases, and lastly we have Lewis theory of acids and bases. First, I will go with the Arrhenius theory of acids and bases. This Arrhenius theory was first given by Arrhenius, and according to him, what is an acid, what is a base? Let's see now. Okay. According to this theory, acids are the substances which can donate the proton, that is nothing but a hydrogen ion. So, according to the Arrhenius, what is an acid? Acid is the substances which has a capacity to donate the H plus ions or to the proton. Whereas, base are the substance which can donate the hydroxyl ion. So, base is a substance which can easily donate the hydroxyl ion. Hence, they are known as what? Bases. Example for the acids are HCl and H2SO4. You can understand this by looking at this diagram. This is an HA is an Arrhenius acid. So, during the reactions, as we have understood, acid must give rise to what? H plus ion. Similarly, I will take an example of Ma. M is my Arrhenius base, okay, which is going to give what? M plus and OH minus. Okay, M plus and OH minus. Look at the board now. I have taken the example of MaOH, which is the Arrhenius base. The Arrhenius base is a capacity to donate what? Hydroxyl ion. Such bases name was given by whom? Arrhenius. So, what is Arrhenius concept? What is a statement of acid according to the Arrhenius? According to him, acid is a substance which can donate the proton, whereas a base is a substance which can donate the hydroxyl ion, that is OH minus ion. You can take the example of HCl for the acids. Okay. You can take the example of HCl. We know that according to the Arrhenius, the acid is a substance which has a capacity to donate H plus ion. Such substances are said to be acids. I will take the example of the bases, that is NaOH. The base is a substance, it has a capacity to donate what? OH minus ion, that is a hydroxyl ion. Such substances are said to be bases. Arrhenius theory of acids and bases, when we are studying, we need to understand the basicity of an acid and acidity of base. But regularly when we are studying the acids and bases, we usually tell the acidity in terms of acid and basicity in terms of bases. But the Arrhenius concept will be reverse of this, and we call the acidity as the acidity of bases and basicity of acids. First, I will go with the basicity of an acid. It is equal to the number of replaceable hydrogen atoms present in one molecules of an acid. So, in a HCl as well as in a HNO3, so how many replaceable hydrogen will be there? Only one. Hence, it is monobasic in nature. Similarly, in H2SO4 as well as with the H2C2O4, you can see that there are two replaceable hydrogen will be there in these two examples. Hence, it is an example for dibasic. Similarly, you can take H3PO4 where there are three hydrogen that can be easily undergo replaceable processes. Hence, it is tribasic acid. This is known as what? Basicity of an acid. So how do I count it? Just by counting a number of replaceable hydrogen atom in the exam. Next we have acidity of the base. It is equal to the number of replaceable hydroxyl ion present in a one molecules of the base. For example, you can see that in a NaOH, I can replace only one OH. Similarly, with a KOH, I can replace only one OH. Hence, it is an example for monoacidic substances. We have one more example, that is CaOH twice and BaOH twice. In these two examples, I can replace the two hydroxyl ion. Hence, it is an example for what? Diacidic bases. This is how the acidity of an basis and basicity of an acid can be easily find out by looking at the example, by knowing the number of replaceable hydrogen atom and number of replaceable hydroxyl ion. Next we have one more theory, that is Bronsted-Lowry theory of acids and bases. So let us see what is the law states. So Bronsted and Lowry are the two scientists. They have given an idea about the acid and bases in their own way. According to that, the acid is a substance which has a tendency to donate a proton, where base is a substance which has a tendency to accept the proton. So this theory which talks about only about what? Proton. This talks only about the proton, where acid is a substance which can donate the proton, whereas a base is a substance which can easily accept the proton. You can take the example here. You can see that these two are the reactant, that is acid and bases, which are giving rise to product. Okay. Now, if you see that, we have understood that acid is a substance which is going to give a what? H plus ion. Correct, no? Whereas a base is a substance which are going to take this proton and become a base. Correct, no? So, example is HCl with the water molecule. So, in HCl, acid is a substance, okay, which is going to give a proton. So, it will become Cl minus. This proton was accepted by the base and become H3O, that is hydroxyl ion. So, this concept which talks only about what? Only the proton, where acid is a substance which can take which donates a proton, where a base is a substance which can accept the proton. And according to him, he called that when acid is losing its one of the proton, it becomes what? Conjugated base. What does he call? It becomes conjugated base. When the substances which are accepting the proton, it becomes what? Conjugated acid. So, this theory was given by whom? The Bronsted-Lowry. So, what does tells about? It talks about the acids and bases, where acid is a substance which donate the proton, whereas a base is a substance which can accept the proton. When the substance is donating the proton, it becomes a conjugated base. Okay. Conjugated base pair we will understand by looking at the example. Then, what is a conjugated base pair? These are the base pairs of the acids and bases. They are differ just by proton. Okay. So, we'll take up an example. Okay. This is a Bronsted-Lowry bases and this is a Bronsted-Lowry base once again. You can see that this is my acid and this is my base. So, we know that acid is a substance which is going to give a proton. Hence, it is known as what? Conjugated base. Whereas, a base is a substance which can easily accept the proton. Hence, it is an example for conjugated acid. You can take this example by looking at this example with the ammonia with water molecule. Here, ammonia is a base, whereas the water is my acids. So, the base which easily can accept the proton, hence it become what? Conjugated acid. Whereas our water is an acid, it can easily give a one H plus ion, hence it becomes OH minus ion, hence it is a conjugated base. So, this is how only the loss of proton and addition of the proton which takes place during a chemical reactions, and this idea was given by who? Bronsted-Lowry. Hence, this involves only the transfer of proton or the loss of proton. Hence, it is known as what? Conjugated acids base base. Okay. We have the list of conjugated base for an acid. So you can see that these are the list of an acid where we are going to write the conjugated base for it. Okay. So conjugated base in the sense the acid has to lose its one of the proton. Correct now? So HCl is going to lose its one proton so that Cl minus. Similarly H2O, OH minus, S3O, H2O, H2SO4, HSO4, NH3, NH2, NH4, NH3, H2S, HS minus, HNO3, NO3 minus, HClO4, ClO4. In all this example, you can see that there is a loss of proton which is taking place. Loss of proton. Next, we have one more topic, that is amphoteric substances. So already we have understood that amphoteric substances are those which can behave like a both acid as well as with a base. Okay. These are the substances which act like both acid as well as with a base. Such substances are said to be what? Amphoteric substances. First, I will take an example of water. Okay. Where I am taking a two water molecule. One is behaving like an acid, one is behaving like a base. Okay. So according to the Bronsted and Lowry constant, acid is a substance which can donate a proton. So after donating one proton, it will lose its one of its proton so that it becomes what? Base. That is a conjugated base. Similarly, base is a substance which has a capacity to accept the proton. Hence, it becomes what? Conjugated acid. So it becomes what? H3O plus ion. This is how the water is behaving like both an acid as well as the bases. Hence, it is an example for amphoteric substances. We have one more example, that is ammonia. Okay. So here the ammonia, after losing its proton, it will behaving like a base. After accepting a proton, it behaving like an acid. So this is how even the ammonia can also behaving like both an acid as well as the bases. Hence, it is an example for amphoteric substances. Remember, amphoteric substances are those which are behaving like both acid as well as the bases. You can remember the example of an acid. After example of water molecule, when two water molecules, when they react themselves, one is acting like an acid, one is behaving like a base. So acid is going to lose a proton, while the base is going to accept that proton and give rise to the respective conjugated as well as with a conjugated base. Now we are going to solve some of the numerical based on this theory as we have studied just now. We'll see how to write. Okay. What will be the conjugated base for the following Bronsted acids? So what they have given? They have given the Bronsted acid. We need to write the conjugated base. Okay. So what are the acids they have given? What are the acids? HF, H2SO4 and HCO3 minus. We need to write what? Conjugated base for conjugated base. Okay. So these are the acids. Acids means what? It is going to lose its proton. Correct now? So after losing one proton, it becomes F minus. In H2SO4, it can lose how many proton? It can lose 2 proton. Okay. So I'll write with the 1 proton, HSO4 minus. If they loses 2 proton, you can write SO4 2 minus. Okay. Next, H3O minus ion, you can write after losing 1 proton, it will become CO3 minus. This is how, it will lose its proton to become a conjugated base. We have one more numerical. The species such as water molecule H3O minus ion and HSO4 minus and ammonia can act like both Bronsted acid and bases. For each cases, given corresponding conjugated acids and conjugated base. So first I'll write the compounds. Okay, H2O, HCO3 minus and HSO4 minus and ammonia. Now I'll write the conjugated base here, and this side I'll write the conjugated acids. Okay, so they have given some of the important compounds as important molecules. To that we need to write the conjugated acids and the conjugated base. So after losing one of the proton, so the water molecules will become OH minus. Similarly, it is CO3 minus. So it is SO4 2 minus, and this is NH2. Okay, NH2. Now I'll write the conjugated acid for this. Conjugated acids in the sense they are going to accept the proton. So H2O, after accepting one proton, it becomes H3O plus, and it is H2CO3, and this is H2SO4. After accepting, it becomes NH4 plus. So this is how for the given compound we can write the conjugated bases and conjugated acids. Hope you all understood this numerical. In the next class, we are going to understand one more theory, that is the Lewis theory of acids and bases. By this, hope you all understood this session. I'll come back with the next topic. Till that, take care, be safe. Thank you.